Hello everyone, my name is Kevin, and today me and my friends Dastan and Kanaka will be teaching you guys about direct proportion and inverse proportion. Now, what exactly is direct proportion? Now, direct proportion is a relationship where two quantities increase or decrease at the same rate. It's a type of relationship where the ratio is a constant value. The formula for direct proportion is y equal to kx, where y and x are variables that change at the same rate, while k being the constant of proportionality. Now, a real life example of direct proportion is like buying groceries. Now, if an apple costs 15,000 rupiah, buying 2 apples should cost 30,000 rupiah, assuming there are no discounts. Now, this perfectly aligns with the formula I've mentioned before, y equal to kx. X being the number of apples, 15,000 rupiah being the constant of proportionality, otherwise known as k, and lastly, y being the total cost of everything. Now, there are a few characteristics of direct proportion. First one being same ratio. Now, the ratio of the two quantities remain constant. If one quantity is multiplied by a factor, the other quantity is multiplied by the same factor. The second one, codependent change. If one quantity increases, the other also increases proportionally. If one quantity decreases, the other decreases proportionally too. Now the third one is pretty simple, 0 point. Now, this tells us that both quantities are zero at the exact same time. Now, what we all have over here is an example of the direct proportion graph. Now, as you can see here, the y and x values increase proportionally, and the diagonal line shows the formula y equal to kx.
Hello, I'm Dastan. So, what is inverse proportion? Inverse proportion is a relation between two quantities where an increase in one quantity causes a decrease in the other, and a decrease in one causes an increase in the other. In other words, the two quantities change in opposite directions while maintaining a consistent relation between them. So the formula of inverse proportion is y equals k divided by x, or x times y equals k, where k is equal to a constant. So the real life example of inverse proportion is when you travel a certain distance, the faster you go, the less time it takes to reach to your destination. But if you go slower, it takes more time. So, what are the characteristics of inverse proportion? So, the characteristics are when one quantity increases, the other decreases. When one quantity decreases, the other increases. The product of the two quantities is always constant. The graph of an inverse proportion is a curve, or can be called a hyperbola, not a straight line. So this is the graph of inverse proportion. So this graph shows an inverse proportion between two variables, x and y. It means that when one value increases, the other decreases. And as you can see, when x increases from x1 to x2, the value of y decreases from y2 to y1. The curve slopes downward, showing this opposite relationship. In an inverse proportion, the product of x and y is always the same. So x1 times y2 equals x2 times y1. For example, if you move faster and the speed is increasing, the time taken for a journey becomes shorter, decreases. This is exactly how inverse proportion works. And this is our references.
Okay, here's a real life example of inverse proportion. Let's say a group of workers is building a wall. If 4 workers can finish the wall in 6 days, how long would it take 8 workers to finish it? Assuming they all work at the same speed, since more workers means less time, this situation shows inverse proportion when one value increases and the other decreases. We can find the answer using the formula 4 times 6 equals to 8 times t. That means 24 equals to 8t, so t equals to 3 days. This shows that doubling the number of workers halves the time needed. So in inverse proportion, as one quantity goes up, the other goes down, but their product stays the same.